Hello, everyone. Today I will talk to you, exactly about what we do at TrustYou to make it possible for travelers all over the world to find their perfect hotel. So just something about myself. I'm from Italy, from Modena, Italy. I have a background in both computer science and mathematics, so I am both, let's say, a computer scientist and a mathematician, or maybe none of them. I then did my PhD in Karlsruhe, Germany. The topic of my thesis was basically development algorithms for network analysis, and I defended my thesis last year in December, and since February, I'm now working as a data scientist at TrustYou with a focus on natural language processing and algorithms and machine learning. So what is it, the question that the Metareview team at TrustYou, so the team I'm part of, is working on? So what is the problem we're working on? So what we want to do is, for every hotel in the world, we want to provide a summary of traveler reviews. And why would we want to do this? Why would we want to provide a summary? Well, I guess most of you, whenever you book a hotel, you first look at reviews from other travelers. And if you think about it, this is quite amazing that we can do this, because maybe 20 years ago, 30 years ago, there was no way of doing this. So whenever booking a hotel, what people could do was basically only pick some hotel based on, basically how it looks from the outside, or just listening from some recommendation from friends who had already been to the city, maybe. And what we have now is it's like having, maybe for a city, we want to go to millions of friends who can tell you their experience about the hotels in that city. And of course, we cannot, on the other hand, the problem is that we cannot really read millions of reviews whenever we want to make a decision about in which hotel to go to. And what most people do is they just read a few reviews, go through a few reviews, and then make their decision based on that. But of course, different travelers also have different expectations, and they look for different things in hotels. So it might be that the experience of the few reviews we read from other travelers does not really reflect our expectations in a hotel. So what we want to do is basically provide a summary containing all the relevant information from all the reviews we can find for each hotel, all the reviews we can find online, and make it like a short summary so that people can read it and immediately get all the important information about the hotel. So these are a few examples of information we can show about a hotel. We can be interested, for example, in how the building of the hotel is, if it's modern, clean, about the view that the hotel has, if it's good for partying, for example, and for example, we can also show information such as solo travelers complain about TV. So this is the also kind of detail we can provide. And So yeah, I just wanted to show how it looks from our website. So this is basically, can you see it? No, you can't. Okay, yeah, all right. Maybe I'll show it later, but let's go on with this. So this information is not only provided on our website. We also provide this information to other websites. You probably know Kayak. And you might have seen this on Kayak already. So Kayak can show you information about hotels, for example, the amenities, the vibe, location. So this information is all data we provide to Kayak. And not only Kayak, but also Google. So whenever you Google for hotel, you see basically, you might have seen this already on Google. So this is also data we provide. For example, here we show the score given by different types of travelers, and also this is shown by Google. This is also data we provide, and it's kind of a shorter version of our Metareview. So basically, what we show here is like a summary, for example, of the rooms. Guests like the rooms, and for example, they notice that maintenance could be improved. These are examples, or information about the location, service, and these are a few examples, basically. So how do we actually get to the meta review? How do we build our meta review? Every week we crawl reviews from many different sources on the internet. We have in our database about 620,000 hotels, and we crawl quite a lot of reviews, about on average 3 million new reviews per week. That's quite a lot of data we have, and we store this data in a Hadoop cluster. And the first step that we do basically on analyzing this data is the semantic analysis of it. So basically for each review, for each sentence in each review, we extract, we map each part of the sentence to categories. For example, this part of the sentence refers to the bathroom, or this other part of the sentence refers to the breakfast of the hotel. And in addition to categorizing these parts of the sentences, we also compute a sentiment for them. So was this sentence positive? Was it negative? And after this part, we basically aggregate this data, and we apply machine learning algorithms to them. And in the end, we generate the text that you saw before. And we provide this text. We showed this text on our website, but we also provide it to Google, Kayak, and there are actually more, hotels.com, Holiday Check, to several other websites. So this is just to give you an overview of the technologies we use to build the meta review. Of course, Python, so almost all of the code we write is written in Python. That's why I'm presenting this here. And we use Luigi for our pipelines. We use Hadoop and Spark for processing the large amount of data we have. And we use, Postgre, MongoDB as databases, and then what you see on the right basically are some of the libraries we use for machine learning, just to give you an overview. Okay, now that I gave you basically an overview of what we do at TrustYou and the meta review team does, I would like to talk to you about a specific problem that my team has been working on in the last months, and specifically it's hotel classification. So the questions we are trying to answer here are, for example, what are the most romantic hotels in town? Say you might want to go to a very romantic hotel, to a very romantic weekend, and you're looking for the best hotel for this. Or you're looking for a hotel that is appropriate for a family holiday. Or here there are some more examples. For example, which hotels have the best casinos, best lake view, are the best ones if you want to go to a golf course, for example, or or the best sea view. I mean, there are many, many questions we can consider. And our solution to this problem is basically composed of these parts that I'm going to describe. So first of all, we basically represent the reviews as vectors. That's the first part we need to do in order to be then able to apply machine learning algorithms to them for classification. And in particular, we consider two ways of representing text, representing reviews as vectors. One is TF-IDF, which I'm going to present soon, and the other one is doc-to-vec embeddings. I'm also going to tell you a little bit about them. And after this, basically, as I said, we apply machine learning algorithms. And another thing we do is we also combine basically the review content with geographical data whenever it applies, whenever it makes sense to improve our classifications. So now I'm going to talk to you about TF-IDF. This is the only slide with formulas. Don't be scared. I'm going to then make an example. To give you an example, it's actually quite a simple method. The idea behind TF-IDF, which stands for term frequency inverse document frequency, is to reflect the importance of a term, which we call T, for a document D in a corpus, okay, a collection of other documents. So we can introduce the term frequency, which is basically simply for term T in document D, the number of occurrences of T in D, divided by the total number of words in D. And we might then assume that a term is important for the document if its frequency is high, right? We could say, okay, if a term appears very often in a document, then this should be quite important. But this is not always the case because, for example, if we consider hotel reviews, we might have that words such as hotel, they're going to appear very often in reviews, so it might not be so relevant for the specific review we are considering. And so basically, there's another term called inverse document frequency, which gives a higher score to terms that do not appear very often in the other documents of the corpus, so are more specific for the document we are considering. And this is simply defined as the logarithm of n, which is the number of documents in our corpus, divided by the number of documents in which the term t appears. So yeah, this will be high if the term doesn't appears only in a few documents. And in the end, the TF-IDF score is simply computed as the product of the term frequency and the inverse document frequency. So to give you an example, let's say we have a document, and this document is, I hope this doc is not too boring, and the corpus we have is composed of, I hope this doc is not too boring, this doc is just as boring as filing tax returns, and tax returns are not that boring. So let's say we want to compute the TF-IDF score of boring, and okay, the term frequency is simply 1 divided by 8, right? Because there are 8 words in our document, and boring appears only once, so that's why we had 1 divided by 8. But the inverse document frequency in this case is the logarithm of 3, because we have 3 documents, divided by 3 because boring appears in all of them. So the logarithm of 1 is 0. So what we have in the end is that the TF-IDF score of boring is also 0, okay? And this makes sense if you think about it, because boring is not specific for document D, right? It appears everywhere. And if we consider hope instead, we have that the term frequency is just the same as for document D. For boring, it also appears once. And, but in this case, the inverse document frequency is higher because hope appears only in this specific document, right? So in this case, we have the logarithm of 3 divided by 1. So in the end, we also have that the TF-IDF score is higher. Okay, now you might be asking yourself, why do we want to compute the TF-IDF score of terms in a document? The idea is that if we compute the TF-IDF score for each term we have in the corpus, then we can represent each document as a vector of the TF-IDF scores of the terms that are present in the corpus. So to give you an example, to consider the same example as before, for document D, I hope this doc is not too boring, we have that we can represent it as this vector that you see here. So you see that in this case, a lot of terms have 0 score. For boring, we saw it before already, and for the other terms on the right, it's basically because they do not appear, right? They are in the other documents of the corpus, but not in D, so their term frequency is 0. Okay, and the idea behind this is that the TF-IDF vectors of similar documents will also be similar to each other, okay? So if you consider, for example, say, you have a document, you have a corpus composed of recipes of different foods, and you consider TF-IDF scores of 2 chocolate cake recipes, for example, you'll have that their TF-IDF scores, their TF-IDF vectors will be close to each other because words such as chocolate, butter, or whatever other ingredients are in a chocolate cake, they will have a very high TF-IDF scores for both recipes. And yeah, in our case, of course, we're talking about reviews, so each document is the set of all reviews for a certain hotel, basically. And the idea is that if we have a training set, so a set of hotels for which we know that they are of a certain category, for example, family hotels, then we can use machine learning algorithms to classify also all other hotels and being able to say whether they are also family hotels or not. Yeah, so creating training sets is quite important. So we actually spent quite some time on this because if you don't really have reliable training sets, then you can be pretty sure that your algorithm won't work well. So we built them based on the review content. We also considered the amenities that these hotels had, and when it made sense, we also used geographical information. For this, we used OpenStreetMap, which is actually quite an amazing project. It contains geographical information for many, many categories. So for us, it was actually very, very helpful. Examples of information it contains are coordinates of coastlines, highways, ski lifts, all kinds of tourist attractions, but also golf courses, casinos, really a lot of information. And I will also now tell you something about word2vec, which is also another, let's say the baseline for another technique we used. And the idea here is quite different from TF-IDF. So the idea here is we say that words are similar when they appear in similar contexts. So we also take the context of words into account and not just their frequency. And what is the context of a word? For example, if you consider the sentence here, the context of fox is the set of words that are preceding and succeeding fox. So for example, in this case, we have a window of 2, and therefore quick, brown, and jumps over are the context of fox. And the basic idea here is that synonyms like intelligent and smart, for example, they will appear in similar contexts, right? And yeah, so the basic idea to create a word2vec model is to train a neural network with a word we're considering, and then the hidden layer of this neural network will be used to represent then the word as a vector, because that's in the end what we want to do, right? Representing words as vectors. And yeah, so we'll have that words with similar context in the end will result in similar vectors. So this is a quite famous plot. You might have seen it already. Actually, on the website where I found it, it mentioned that it's illegal to talk about word2vec without showing it. So here's the plot. And so what you can see here is quite nice, is that basically word2vec encapsulates relations between words. And in particular, we have that, for example, the distance between similar words is also, pairs of similar words is also the same. So the distance between king and queen, for example, is the same as the distance between man and woman. And we can write this nice equation that basically king minus, it's king minus, actually I wanted to have it here, king minus man plus woman is equal to queen, which actually makes sense. And in the end, we don't want to just represent words as vectors, we want to represent reviews, right? So documents. And what we use is basically doc2vec, which combines, let's say, vectors of all words that are in a document into one final vector, let's say. Okay, so to give you an idea then of how our classification pipeline works, the first thing, as I said, we want to transform reviews into vectors. So we do this with either TF-IDF or doc2vec embeddings. And since we have reviews in many different languages, we do this separately for each language. And then, again, separately for each language, we use a classifier called gradient boosting. I'm not going to talk about it now because we don't really have enough time for that, but it's basically an ensemble of decision trees. You can take a look at the Wikipedia article, or there are many resources online. And basically, in the end, what we do is we combine the predictions of the classifiers for each language into one final classifier, giving weights based on the number of reviews we have in the different languages. So basically, for a hotel, we have 90% of reviews written in German and only a few reviews in Italian. Then we'll give a higher weight to the German review, to the German classifier. All right, sounds like everything should work fine, right? This makes sense. It did work. It does work quite well in most cases, but now I would just like to tell you a few examples where a few problematic cases we have. They're also kind of funny. So one problem we had is that when we were classifying golf hotels, we basically realized that some hotels that were actually not close to any golf course, they got positively classified. And actually what was actually quite weird was that only the German classifier, so the classifier for the German language, was really confident about these hotels being golf hotels. But for the other languages, this was not the case. So we were really confused what was happening and why only Germans were talking about a golf course. And No, what then we realized is that the English word Gulf is actually Golf in German. So basically the reviews were referring to the Gulf of Naples, so they were not really reviewing to a golf course. But still, there were a lot of mentions of the word golf, of course. And another problem we had is that basically in a small town outside Atlantic City, there were a lot of mentions of casino-related terms, actually a lot of positive mentions, and although there was no casino close to this hotel, so we were a bit confused. And basically it turned out that, in fact, in these towns, that are a bit far from Atlantic City, people were really happy about being far away from casinos, like to be in a quiet place, and that's why they had all these positive mentions of casino. Yeah. So basically, the solutions we had, these are, of course, quite complicated problems. So, but with the solutions we found, so there's still room for improvement, of course. But the solutions we found so far is basically to also use geographic data. These also help quite a lot, for example, with problems such as, casinos, golf courses. So we could also use this information to make sure that we don't classify hotels that are not close to the amenity we're considering. And in addition to this, we also perform quite an extensive cross-validation in order to be sure that we pick parameters that can guarantee us high precision. And then ideas for future work, we could consider actually disambiguation techniques. So this is actually an idea that a colleague gave me quite recently, so this is something we might look into. And also we could think of combining TF-IDF with word embeddings, because what we're doing right now is for different categories, we are just picking the one that works best between TF-IDF and doc2vec embeddings, but basically there are also ways of combining both, so this might lead to even better results. So this is basically what I wanted to present to you. If you have any questions, feel free to ask, or you can also contact me. This is my email address, and you can also feel free to take a look at our website. So basically there you can find a little bit about what the engineering department at TrustYou is doing, also something about job openings if you're interested. And yeah, that's basically what I wanted to tell you. Thank you.
Bring the microphone to you. So let's see. Here I have some hands. Okay, so let's start from the bottom.
Thank you. Hi, thank you for the nice talk. Do you have any intuition on when TF-IDF works best and when doc2vec works best?
Well, what do we... Yeah. Okay, so my intuition, and something that has been shown in practice, is that doc2vec doesn't work very well when your document is short. So it's in those cases, it might be the case that TF-IDF is working better. Yeah, this is basically this is something we still have to investigate a bit more, though. So basically, what we did was mostly comparing the two methods and seeing which one was performing best. But yeah, this is also maybe something we can investigate a bit more, like why exactly this is happening. But this is certainly one of the reasons. So the length of the document influences this quite a bit, and yeah.
Hi, first of all, thank you. I think it was a great talk. I was wondering whether you consider that maybe many of those reviews might be fake, and whether that's a problem that you need to tackle.
Yeah, this is actually a very good question. So one thing is, in general, at TrustYou, we're only considering reviews from verified sources. So, for example, only reviews from Booking.com, where you can know for sure that one can post a review only if this person has really stayed to the hotel, or Google. We also use reviews from Google. So we don't really use Google from sources from which there's no way of really identifying the person. But yeah, apart from this, whether the news is fake or not, the reviews is fake or not, this is not something we're checking yet. But this is also something we talked about. So there's. It might be that in the future we certainly plan to consider this as well.
Rodney. There you go.
Thanks for your talk. It was really good. Do you have any recommendations for tools for labeling data? I struggle. For labeling data, do you have any recommendations for tools or applications that help with that?
Okay, what do you mean exactly? Like labeling?
So say you've got web pages and you want to label the data you find on the HTML. Do you have any tools that help with that?
I'm not sure.
Yeah. So for building a training data set, you've got some reviews.
Okay, for labeling,
you
like
want to
saying.
start labeling that, and you've got lots of them to do, right? So
Yeah, sure. No,
is there any tools?
we didn't really use any tool in our case, so we mostly, so we consider mostly the review content information, the frequency of terms, and we looked at amenities and things that are basically specific to our problem, like specific to, for example, lake hotels, so the vicinity to lakes, for example. So we didn't use any specific tool, so
Okay.
Unfortunately I don't
Thank you.
have any recommendations.
I'll keep looking.
Thank you for the great talk. You mentioned that example with German where golf means two things.
Mm-hmm.
Do you know how word2vec behaves when you have synonyms like that fall on the same word?
Like golf with different meanings?
Yeah, like what does the German golf vector look like?
Yeah, that's a good question. I mean, no, I'm not sure exactly. This is, a difficult question. Yeah.
It's Google Translator, something kind of relatable.
Google Translator, like if we can use that, or what is the question?
Is it like, for example, like golf, do
Mm-hmm.
you use the Google Translator to unify to language?
No, we don't. So actually, we really like the classifiers. We consider them really separately. So we don't translate any text. We have separate classifiers for German, separate classifiers for English. We don't use Google Translate or anything.
Hello, thank you for the talk. I wonder about the data pre-processing. So there is some data cleansing that you had, a major one that you do.
Mm-hmm.
So kind of clean up the data set and perhaps identify a name of places or things like that.
Yeah, so I can't give you too much details about this because actually this is done by a different team. This is not exactly, so there's another team that really works on, that performs the semantic analysis and also takes care of, cleaning the data, for example, removing stop words, tokenization, lemmatization, all this kind of things. So there's a team that is taking care of that. And so, sorry, your question, you asked me what we do exactly, or?
I was wondering some general ideas if you could talk a little about that.
So I can give you just these general ideas because this is something that a different team does. I don't know if maybe Stefan, you want to add something on this, or it's okay. Well, maybe we can take this then offline. There are other also people here from my company also can give you maybe more details.
Okay, cool. Thank you.
Perfect. Thanks so much. Okay, folks, we are out of time, so let's thank our speaker again.